So according to what we just learned, the measurements accuracy should be reflected in the product of 2 or 3 or 4 numbers. So if you multiply 3.0 by 3.0, since this has 2 places and 3.0 has 2 places, my answer should also have 2 places of accuracy. So my answer should be 9.0. Now the idea with multiplication and division is essentially you have to look at the number of significant figures that your measurements have and then round off your answer to contain the same number of digits. So if you are multiplying a number that has 2 places of accuracy and you're multiplying by a number that has 3 places of accuracy, your answer should have the same number of significant figures as the least accurate measurement. So in this case, 2.0 has 2 places, 3.00 has 3 places, so my answer should have 2 places of accuracy, 6.0. Unfortunately, the idea with adding and subtracting and rounding off measurements is in principle the same, but the process is a little bit different. When you're adding numbers together, you can go ahead and add them as normal, like 14.3 plus 3 on your calculator will tell you 17.3. Now, if you're concerned about measurements and the accuracy of your answer should reflect the accuracy of the measurements that you make, when you're adding and subtracting, you have to pay attention to the places of accuracy. Not the number of significant figures, but the place of accuracy. So in the case of 14.3, it's been rounded to the nearest tenths place. In the case of 3, it's been rounded to the nearest ones place. So my answer can only be as accurate as the measurement I made, or the least accurate measurement that I made. And so since this 3 is measured to the ones place, my answer should be rounded to the ones place, or should be 17. Here's a simple adding problem. This simple adding problem, 14.105 and 10.85 added together, you may notice that 14.105 supposedly is accurate to this place, and 10.85 is accurate to the hundredths place. So my answer is only going to be accurate to the hundredths place. So when I write down my answer, it should be 24.96. A digit behind causes me to round up. One of my favorite questions is what's the sum if you add a dollar plus a penny? Now, of course, this depends on the way you interpret this. It depends on what you mean by a dollar. If you mean a dollar that looks like this, and you're adding to it a penny, then the sum is going to be pretty straightforward. The dollar written like this is accurate to the hundredths. A penny is accurate to the hundredths, so the sum would be a dollar and a penny. But what happens if you meant a dollar like this, and you add it to a penny, like so? In this case, since the dollar is rounded out to nearest ones, the sum is only going to be accurate to the ones, and so the sum would only be a dollar. Now the big question is, what's the difference between these two? Well, this one here, 1.00, or I'm going to call that a dollar, is exactly a dollar rounded to the nearest hundredth, or rounded to the nearest penny. It could be 4 quarters. It could be a crisp $1 bill. However, a dollar like this represents some quantity of money that's bigger than 50 cents and less than $1.49. It is rounded to approximately a dollar given one place of accuracy. It might be a bunch of change that you have in your pocket and you look at it very quickly and you know that it's more than 50 cents and it's less than $1.50, and you say that's about a dollar. And so if you add about a dollar and a penny to it, you're still going to get about a dollar, which is one place of accuracy. So when you're multiplying and dividing, you essentially have to count the number of significant figures and then round off your answer contain the same number of places of accuracy. If your measurements have 2 places of accuracy, then your answer should have 2 places of accuracy. However, if you're adding and subtracting, it doesn't really depend on the number of significant figures. It depends on where those measurements have been rounded off. and the place of accuracy. So if you have two measurements and one's been rounded to the ones place and one's been rounded to the hundredths place, the sum is only going to be accurate to the ones place.